Hi everyone, welcome to Chem Help ASAP. In this problem set, we are going to balance redox equations. Now we will very briefly go over the steps for balancing redox equations, and then we'll balance an equation in basic solution and an equation in acidic solution. Let's take a look at our problems. So here is our problem on the right-hand side of the screen, and we have our steps on the left-hand side of the screen. So let's just very quickly go through our steps here. The first thing we're going to do is we're going to assign oxidation states. Once we have those oxidation states, we can identify our reduction and oxidation half reactions. Once we have our half reactions, we're going to balance everything except for oxygen and hydrogen. Then we're going to use water and acid to balance our oxygen and hydrogen. And finally, we're going to balance our charges with electrons. Now, once we have our half reactions balanced, we want to make sure our number of electrons are going to be balanced. So we might have to do some multiplying there. Then when our electrons are the same, we can add our two half reactions. Again, this is a place where we might need to add or subtract identical species. If we're working in a basic solution, what we're going to do is we're going to neutralize all our acid with base and adjust the equation that way. Now for this first problem, we are going to do it in basic solution, and our next problem we will work in acidic solution. So you can see both ways of doing these equations. Now to our problem, step one, let's assign oxidation states to all of our elements here. So we've got chlorine gas, that's going to be a 0. Of course, our aqueous chlorine ion is just -1, like stated. Our ClO, it has an overall charge of -1. Of course, oxygen is -2. That's going to make our chlorine +1. This is an equation where chlorine is actually undergoing both oxidation and reduction. So we can just see the changes here from 0 to -1 and also from 0 to +1. Now, our 0 to -1 is going to be our reduction, and our 0 to +1 is our oxidation, but this is going to become a little more clear once we get our half reactions in. Let's start with our chlorine gas going to our chloride ion. So now we need to balance all of our elements except for oxygen and hydrogen. This, of course, is very easy. I just need to put a 2 here in front of my chloride ion, and all my atoms are balanced. I don't have oxygen or hydrogen, so I don't even have to mess with that. Now I need to balance my charges by adding electrons to either the left side of the equation or the right side of the equation. Right now, the left side of my equation is still neutral. It has no charge. And the right side of my equation has an overall charge of -2. That means to balance my charges, I'm going to add 2 electrons to the left-hand side. Here is a common mistake that students make. They think that balance the charges means that the charges have to be 0. No, it just means you have to have the same charge on both sides of the equation. So let's rewrite this equation a little more neatly. And here you can see I have my balanced half reaction typed out more clearly. And now that I have my electrons written in, it's a little bit easier to see that this half reaction is my reduction half reaction. Let's take a look at my other half reaction. So my other half reaction is chlorine gas going to ClO. Now for anyone who's interested, ClO is actually hypochlorite. But we don't need to know that to finish our problem. So just like before, we need to balance elements except for oxygen and hydrogen. So we will need a 2 here. Now this half reaction does have oxygen in it, so we are going to have to balance our oxygens by adding water. Since we have 2 oxygens on the right-hand side, I am going to add 2 waters to the left-hand side. Now I need to balance my hydrogens by adding acid. So I have 4 hydrogens on the left-hand side. So I am going to add 4 H pluses to the right-hand side. Now all of my atoms are balanced. Next, I need to look at my overall charges and make sure I balance them with electrons. The left-hand side here is very easy. Both of these are neutral molecules, so the left-hand side is 0. My right-hand side, I have got a -2. This is a +4, so overall I've got a +2 charge on the right-hand side of the equation. To balance this out, I am going to add 2 electrons to the right-hand side of the equation. This means I now have a -2 over here. You can see now the right-hand side of my equation is 0, which is the same as the left-hand side of my equation. Let's rewrite this a little bit neater. Here is my neater reaction, and it becomes very obvious that this is my oxidation half reaction. One thing to note here, if you have a reduction, you're going to have an oxidation and vice versa. If you end up with half reactions that have electrons on the same side, go back, something is wrong. Now that we have our balanced half reactions, we need to take a look at the number of electrons and see if we need to do any multiplying to make our electrons equal. Well, the great thing about this reaction is I have 2 electrons on both my reduction half reaction and my oxidation half reaction. So I just need to add these 2 half reactions together. Let's rewrite my reduction right underneath my oxidation so it makes it a little bit easier to add these up. Now we need to add or subtract identical species. Of course, the first thing I always like to do is I always like to make sure, yes, my electrons add out. Next, I'm going to see, is there anything else that I need to add together or add out? And I see that I have my chlorine gas both on the left-hand side of the equation. That means those are going to add together. Nothing else adds or subtracts out, so I'm just going to pull everything down, remembering to keep things that are on the left-hand side of the equation on the left-hand side of the equation and vice versa. So here is my balanced equation. You can see I just brought my water down. Here is where I added my 2 chlorines together. My chloride and my hypochlorite stay the same, as well as my acid. This equation is balanced, but it is in acidic solution. Let's work through converting this over to basic solution. So to convert to basic, I need to add hydroxide in to neutralize my acid. Because I have 4 H pluses, I am going to add 4 hydroxides. That will neutralize all my acid. But of course, whatever I do to the right-hand side of the equation, I must also do to the left-hand side of the equation. So I will add 4 hydroxides there. Now notice these 4 protons and 4 hydroxides are going to combine to form 4 water molecules. Now I have water on the right-hand side of the equation and on the left-hand side of the equation. So I can do some simplifying. These 2 waters are going to go away, and this 4 is going to become a 2. So they subtract. They add not completely out, but they simplify. Okay, this is technically balanced now, but let's put it all together, written out more neatly. Okay, so here is my balanced equation written more neatly, and you can see I went ahead and put the states in as well. I left those off initially just to keep things simple. There's no need to rewrite all of that while you're trying to work through all of your half reactions. So that is our first problem. Let's take a look at our second problem. Here's our second problem. I'm still going to keep the steps on the left-hand side of the equation just so you can reference back to them. Okay, let's get oxidation states in here. Oxygens are easy. That helps us figure out arsenic here. Again, I'm going to use oxygen to figure out nitrogen. Same thing with our arsenic acid. This must be 5. Of course, hydrogen is +1. And here we've got nitrogen at +2. So it's pretty easy to see that arsenic is changing oxidation states and nitrogen is changing oxidation states. Now at this point, you don't have to worry about identifying what is being oxidized and what is being reduced, although you can. Our arsenic is undergoing oxidation and our nitrogen is being reduced, but that again will become more clear when we pull out half reactions. Let's start with our arsenic. Here are two species with arsenic, and oh dear, I already see an error. I've dropped my 2 here. Obviously that is rather important because the first thing I'm going to balance are my arsenic atoms, which means I need a 2 here. Okay, arsenic is balanced. Let's get these oxygens balanced. I need 5 waters on the right-hand side for that. Now I need to balance my hydrogen atoms, so I am going to need 4 protons on the right-hand side. Now that I have all my atoms balanced, I need to balance my overall charges. On the left, both of these are neutral, so I have an overall charge of 0. On the right, my acid is neutral, but I have 4 protons, so I've got an overall charge of +4. This means I'm going to have to add 4 electrons to the right-hand side of the equation. Again, now it becomes easy to see that this is my oxidation. Let's rewrite this a little neater. Here is my balanced half reaction. Now let's deal with our nitrogen. Again, here are our species containing nitrogen. Thankfully, my nitrogens are balanced, so I don't have to mess with that. Let's balance our oxygens. So we need to add 2 waters to the right-hand side. Now we need to balance our hydrogens. Let's add 4 protons on the left. On to overall charges. Over here on the right, let's see, we have a +4 and a -1. And on the right, I have neutral. So if I add 3 electrons to the left-hand side, I am balanced in my charges. Again, here is my rewrite a little more neatly. And of course, now that electrons are in, it's very easy to see that this is my reduction half reaction. Again, it's a nice check to make sure you have 1 oxidation and 1 reduction. Now that I have balanced my half reactions, I need to combine them. And to combine them, I need to check electrons. So I can see in my oxidation, I have 4 electrons and my reduction has 3 electrons. So right now, these electrons are not going to add out. So I am going to need to multiply both of these half reactions in order to get my electrons equal. So my oxidation is going to be multiplied by 3. And my reduction, I am going to multiply by 4. Then I will have 12 electrons in each half reaction and I can add them. So here are my half reactions. Once I have multiplied everything through, we are ready to add these half reactions together. All right, let's work with what adds out. So again, my electrons add out, which is the first thing I always like to check. Now let's deal with waters. I have 8 waters over here, so that 15 is going to turn into a 7 because they subtract. My protons as well, that 12 is going to go away, and that 16 is going to become a 4. I don't have any of the same species on the same side, so I'm not going to be adding things together like I did in my previous example. Now I'm just going to pull everything down and write it a little more neatly. Here is my balanced redox equation. Now this one we're going to keep in acidic solution because we actually have an acid here. And I have also put my states in just to make it a little more complete. There you go. That's 2 balanced redox equations, 1 in basic solution and 1 in acidic solution. Thanks so much for watching, and I hope you guys found this helpful.